I did send out the announcement about your test. I really meant to open your test already, and I realized when I looked at the work today that your test wasn't open yet. So I will set it up right after our session. I had it ready, I just didn't have the honor lock thing set up. So I will get that done. It will be due on the 22nd, so Sunday at midnight. It's test 3. It is not test 2. All right, 20 questions and 90 minutes. Any questions about the test? All right, so this is one of your reviews if you do, and this is the one that's worth the most bonus points, up to 5 depending on your score, added to your test. So it's always a good idea. If you have any requests anytime for problems, just let me know, and I'll be glad to do what you would like. All right, so I just thought we'd start through and do some different ones. So the first part of this section, it is the review, and it is module it's test 3 practice problems. Let's see. We'll look and see what module it is. So the practice problems are, they probably fall under module 6. Yes, it looks like that piece is inside module 6. So module 6, and it will cover 5 and 6. Any other question? All right, so we'll just do some. I didn't leave a date this time. Like last time I left, we had no class one day. That was kind of to give you time to do your test. Just with the schedule, I didn't have room to let it happen this time. So we'll see for next time. Okay, so question 1. And the first part of the this section was factoring, and then at the end we were solving quadratic equations, and we had 3 techniques there, by factoring, by square root method, and by quadratic formula, which make sure you memorize quadratic formula. All right, so we have 56W 17th plus 56W to the 12th minus 8W to the 10th. Right, so the first thing you can always try with factoring is a GCF. This one is going to have a GCF. 8 will go into 56, so we're going to have an 8. For your variables, W is in everything, so take W to the 10th, the lowest one. To get back there, 7 times 8 is 56, so we need a 7 divide if you get stuck. You have 10 W's, you want 17, so you need 7 more. The variables that they subtract, right? And 8 into 56 will go 7. You have 10 W's, you need 2 more. And here we have all the last term except we need a minus there, so we will multiply by a -1. Anytime you get something with this high an exponent of 7, it's not going to do more. If you did GCF, that's all that you're going to do on that one. Right. Okay. The next couple, so factor out the GCF. They want you to still factor the whole thing, not just write the GCF. All right, so number 2, we have 20 x to the 6th plus 8x to the 4th plus 12x cubed. All right, so you try your smallest one, but you can't use an 8. So go lower than that. 4 goes into everything. So use a 4. And for your variables, we can use x cubed. To get back there, 4 goes into 25 times. If 3 x's, you need 3 more. 4 goes into 8 2 times, and you need 1 more x. And 4 into 12 will go 3, and you already have the x cubed. This is not going to factor more because it has a 3 here, and we've already done GCF. So that should be our answer. Your third one is similar. It just has lots of variables, so we'll do it. Mainly be careful. So 12x to the 4th, y to the 5th, plus 28x cubed, y to the 6th, plus 4x squared, y to the 4th. All right, so GCF, test the lowest one. Does 4 go into everything? Yes, it does. All right, for your variables, you have x in everything. You can take x squared. You have y in everything. Take y to the 4th. All right, big set of parentheses to get back there. We're missing a 3 and an x squared and a y. Next one, we have a 7. With 2 x's, we need 1 more. So that's 1 more here. We have 4, we want 6, so you're missing 2. Last term, you have the whole thing. You need to write the 1. This is not going to factor more. If it didn't have this y here, you could try it. Also, this x here is a little bit of an issue. And the y squared here. So it's not going to factor more. All right, so that was taking out the GCF. The next couple we have are grouping. With grouping, it is 4 terms. And so you break them into a group. Here's a group. Here's a group. And then take out the GCF. So in the first one, we can take out an A. And that leaves a C and a minus 7. In the second one, we can take out a 2. And to get back there, we need a C and 2 into 14. We need a minus 7. What you hope happened is that you get a common binomial, that these match. And you did. Whoops. So you get C minus 7, and you pick up these outside pieces, A plus 2. The order doesn't matter there. You can always move the whole parentheses. All right, we'll go ahead and do one more grouping. This one, because it starts with a negative on the third term, we will need to take out a negative. So 4 terms, we'll do grouping. In the first group, we can take a y, and that leaves x plus 8. Because this third term starts with negative, we'll need to take a negative out, and a 2. And that leaves us x. We took the negative out, so we have plus 8. I would double check that piece. Negative 2x, that's good, and negative 2 times 8 is negative 16. So we're good. And common binomial of x plus 8. To get back there, we need these missing pieces. Y minus 2. Okay. And you don't have to put the dot in there. Just don't put a plus in between those. Factoring is always a product. All right, so I'm going to skip the next grouping one. Then you have trinomials. Trinomials are the big family. And so first we have the nice ones that start with a 1. And so you do your parentheses, you do like signs both plus. Because it ends in plus, that's why they're alike, and you take the sign in the middle term. Split the x's, and you're looking at 54. 9 and 6 might pop in your head. If it does, use it. If it does not, then you make the list. 1 times 54, 2 times... So 54 divided by 2 would tell you 27. 54 divided by 3, and it should go in there because you can add those. 5 plus 4 gives 9, and 9 is divisible by 3. So 54 should be. Great, 18. I think 4 doesn't go. 5 doesn't go because it doesn't end in 0 or 5. You can try a 6. And there's your 6 times 9, and that's the one that's going to work. If you didn't see it at that point, you could make the rest of the list, and then look closer. They're going to add to give 15, 9 and 6. It doesn't matter about your order on this one. When you have like signs, you can just throw them in, and we have ones here. I would still do the little tiny check outside and inside. So 6x multiplying plus a 9x is your 15x, and you're good. All right, let's do the next one because we'll have different signs on it. We have x squared minus 7x minus 18. So it is a trinomial. There is no GCF. So we can go ahead to the parentheses. When it ends in negative, that tells you different signs, and you don't have to look back. Split your x's. All right, you're multiplying to get 18, and you're going to subtract with different signs to get 7. 9 and 2 is going to be your choice, but if it doesn't pop in your head, you make the list. 3 times 6, 4 doesn't work, 5 doesn't work, and then you get 6 times 3. All right, now you do have to be careful when you put them in, the numbers into the parentheses here, because you want the right one with the right sign. So we want a negative 7, so we're going to need a negative 9 and a plus 2. And we'll check. Minus 9x plus 2x gives a negative 7x, and we're good. The next one just has an extra variable. It is a trinomial, though, with no GCF, so do your parentheses. This says do like signs both plus. Split the x's. I want to split the y's on the end. All right, and then I'm multiplying to get 63. 9 and 7 pops in my head really fast, and that's going to work. They will add because they're like signs, and 9 and 7 adds to give 16. If it doesn't pop in your head, make the list. Right? If it does pop in your head right away, use it. If it doesn't come to you right away, you need the list because it's not going to. You don't want to just sit there and spin, spin, spin. All right, I'm going to check this one with a whole foil to make sure I'm getting this 16xy. Most of the time we don't do the whole thing, we just do the middle. All right. So, whoops, and I started to do the middle. Okay. First is x squared, then we have outside plus 7xy, inside plus 9xy, and last is 63y squared. These combine, and it looks like we're good. Back to the original. So that was our goal. All right. right, this next one starts some of the two-step problems. Looks to me like it has a GCF to begin with. Easy to spot because everything's even. Also, there is a W in everything because you're at W to the third. So that's a clue. So step one, we'll do a GCF. So we can take a 2 out of everything and 1 W. Right, you should always write this line. Don't try to skip from here to breaking it down more. Right, so we need left W squared. Plus 2 into 12 will go 6. And we need one more W. And this will be negative. And then 2 into 54. 27. All right. So now we have to see if this will do more. This 2W is just going to come down with our answer, but otherwise we ignore it. All right, and it is a nice trinomial with a coefficient of 1. We're going to have different signs. Split the W. And for 27, I'm thinking 9 and 3. That's all I can think of that multiplies to give 27. And would that subtract to the 6? Yes, it would. Right? If it didn't, then you would try to make your list. And that's about all you're going to get except 27 and 1. Excuse me, 1 second. All right. So we have different signs, and we want to get a plus. So this plus needs to go with the biggest one. So plus 9 minus 3. We'll check. I'm just checking to the line above. Kind of did this check in my head to get back up here. So this is minus 3W plus 9W equals 6W. So this is why you want this middle line written, because you're not thinking about 12 anymore. This is where you're trying to go. And so we should be good there. Okay. That's just the answer. And it give a hint. Okay. This one looks ugly. Nasty numbers. I started blow right by that one. That would be mean, huh? I am hoping that 4 divides into everything, but I have to check it. Right, so 68 divided by 4. So I'm looking for a GCF. Yes, it goes into 68. 288 divided by 4. Yes, it goes 72. So we can do a GCF. Take a 4 out, one big set of parentheses. It leaves x squared plus, this should have had an x on it. Right, plus 17x plus 72. And then the 4 comes down. And this should be easy to you. It's a nice trinomial with a leading coefficient of 1. Like signs, both plus. Split the x's. You're working on 72. 9 times 8 pops in my head. That does add to give 17, so you're good. Go with it. If it didn't pop in your head, you make the list. You do 1 times 72, 2 times whatever, and you keep going until you find the right one. And our check, 8x plus 9x, 17x. So we're good. All right. Okay, next one. I'm not sure why this is thrown in here. Because it's an easier one and it doesn't have a GCF. It does have different signs. Let me just make sure it does factor. So you have x squared plus 3x minus 4 different signs. Split the x's, and you're going to use 4 and 1. And you want plus 3, so it's going to be a plus 4 minus 1. Minus 1x plus 4x, 3x, and it's good to go. So that one was easier than what we've been doing. All right, I'm going to skip the next one. That is extra variable again. All right, and this looks like the other kind. It does not have a GCF. And when I showed these in class, I showed you 2 ways. I did it by trial and error, or I did it by changing the problem into 4 terms and did it by grouping. Anybody have a preference? All right, I think I'll do the grouping. So I have to first multiply the 6 times 35 to see what to make my list with. So 210 is what I'm looking at. So what I'll multiply is to give 210. So 1 times 210, 2 times 105. It is divisible by 3. 3 times 70. We'll check for 4. No. Should be divisible by 5. So 5 times 42. And I am thinking that's going to be the choice because they are going to, this sign tells what they're going to do. They're going to subtract to give this one. So one will get a positive and one will get a negative, and that's going to work. All right, so if you're doing this with the change to 4 terms and do grouping, you keep the first and you keep the last. And this one you're making into 2 terms. And so I want positive, so I'm going to put that with the bigger one. And each of these will get a z. So I'm going to have plus 42z and minus 5z. Then you factor it by grouping. So in the first term, we can take out a 6z, and that leaves z plus 7. On this one, make sure you take out a negative, because it's negative on the first term, a negative 5. And that leaves us a z. We pulled this negative out, so it's plus. We'll double check that, negative 5z and negative 35. So we're good. We did get a common binomial, so we'll take that out and pick up the line above. So 6z minus 5. This was a plus. That was here. The next one you can do the same way. And your number is not really big that you have to pick. 15 times 1 is 15. It's also not bad with trial and error because your last choice has to be 1s to get a 1. So I'm going to skip it. $16 is just going to be a 2-step problem. And they even give you a hint. Right, and it says take out the GCF. We would really like it if it's 48, but it's not because that doesn't go evenly into 80. So we have to go lower than 48. So things that go into that. Maybe we could try an 8. So let's try 124. 2.5 doesn't go. All right, so I am going to show you, you know there's at least a 2, and so maybe a 4. I'm going to show you if you get really stuck on that, because those are hard numbers, how to do it. All right, so I have 8 times 10, and I have 2 times 4, and 2 times 5, and 4 is 2 tubes. All right, and 124, I know there is a 2, it is 62, and there's a 2 here because it ends in an even digit, and that will go 31, and that's all it will go. And 48, I know 6 times 8, and 2 times 3, and 2 times 4, and your 4 will keep going. All right, so it has to be common. That's what the C stands for, greatest common factor. So I'm going to go with 2's. The most I can take is 2 if there are 2 in each one. All right, I can't use a 5 because there's no 5's here. I can't use the 31. And the other thing that's here is a 3. So 4 is the GCF. That is how to find it, definitely, if you get stuck. All right. And that leaves me 4 goes into 80 20 times. And 31. And 4 goes into 48, 12. All right, not a very pretty problem. The 4, just remember to bring it down. All right, I think I'll do this one the other way with trial and error, and the reason is because I can remind you about that one shortcut. So if you like the grouping, tune me out and do it yourself, and we'll match up the answers. Okay? So I have 20. So I have 20 and 1. I have 10 and 2. I have 3 doesn't work. I have 5 and 4. So those are my choices. For 12, I have 1 times 12. 2 times 6, 3 times 4, and they all flip over. So, possibly a lot of work. 6 times 3, 18 possibilities. All right. You can throw out a bunch, though, because we have an even digit here and an even digit here. They're going to have some common factors in the parentheses, and they're not allowed to, because we already took out the GCF. So, the 10 and 2, because it has even in both, it's not going to work with anything, right? If you try the 12 and 1, 12 goes in the parentheses with the 2, GCF. This one has even in both, it's out. The 4 goes in with the 2, it doesn't work. This one puts the 4 in with the 10, they have a GCF. This one both even, and this one a 12 in with the 10. So 10 and 2 is not working with anything. From the ones that are left, I would try the 5 and 4. And this parentheses is going to kick out any even digit in the second spot. So 1, 2, 3, 4. Those are out. And we're doing like signs both plus. So we could try 4 and 3. And there is 15 W plus 6 of 4 times 4, 16 W. And that's the right choice. So I got lucky knowing that one trick about common factors. And so this should be your answer. 4 times 5W plus 4 times 4W plus 3. Make sure when you're writing these out in your work that you're numbering the problems and you're showing your steps. If I see your work nice and I can find the problems, if you took out the 4 and you missed something else, you would probably get some partial credit, because I do review the work when I look at your test. All right, so let's see if that was good. They've just switched the order of the parentheses. Grouping should have given you the same answer. I'm going to skip this one. You have a GCF there. It is a 2z squared, and then you keep going. That one has a GCF. Those y's have to go away, and there is at least a 5 in there. This one has no GCF. It's going to be do it by grouping or do trial and error. All right, and that gets us down to squares. This is a rather nasty problem that came up. The software has a random generator, and so sometimes that might happen. But it actually, and we switched to 2 terms now, right? We went through the 3 terms, and we switched over to 2 terms. Your choice with 2 terms is squares or cubes, and check the exponent. So you have an exponent of 2. This one actually has a GCF in it. It has a 5 in it. So let's take the 5 out, and that leaves x squared minus, let's see, 405 divided by 5. X squared minus 81. So that's much better. So it's not a bad problem. It just looked bad. It looked scary at the beginning. 5 is done. This is a difference of squares. It will be 2 terms. It'll be minus, and they have to be perfect squares. You always have one parenthesis with plus, one with minus, and you use the square roots. And that's such a nice pattern. You don't have to even check. All right. Let me do 22 first, and we'll look back at that one and see if it might be one of the perfect square trinomials. It's not when we look at it right now. All right, this one is a nice difference of squares. It just has a number and a variable. There's not a GCF, but 49 is a square, so is 81. So you will use 7x plus and minus, and for 81 we'll use a 9. Don't try to write this with an exponent. These are different. You can only use that exponent if they're identical. All right. I didn't like the looks of 21, but we'll go back and see what happens with it. All right, definitely we have a GCF. We have a 2 and a t. That leaves t squared plus 2 into 44 goes 22 times. And we need one more t. And here, 2 into 242 will go 1, 2, 1. And the t's outside. So this actually is one of the perfect square trinomials, which is in the same section as the squares and the cubes. I don't know that I would think of that if I didn't see where it was coming out of, but it starts with a square and it ends with a square. Square root of 121 is 11. So with anyone like that, I would guess the square roots. It will be regular sign rules, like signs both plus. And 121, the square root is 11. Make sure you can find a square root on your calculator. Right, so it is second square root 121, close, enter. There you go. And the 2t needs to be with it. All right. Here they could write it. I would not bother to write it like they did. It's going to count you right if you write it just like this. But when they are identical, then you can write it with an exponent if you choose. All right, 23 is a nice example of these. It kind of jumps out at you. 9x squared. Otherwise, it wouldn't be such a nice problem. It does start with a square and it ends with a square. So we'll do our parentheses. This says do like signs both plus. Square root of 9 is 3, and we'll need an x. Square root of 100 is 10. And you just have to check and make sure the middle works. So this is 30x plus 30x, and that does give 60x, and you are good. So it is a perfect square trinomial. All right, that brings us down to another kind. And this problem is also two terms, but notice the exponent of 3. And so that tells you it is cubes. If you can get cube roots, right? So cube root of y cubed is y. Cube root of 8 is 2. On your calculator, you have to tell it the root first. So 3, second, and any root. It's putting the 3 into that x, and then you put the 8, enter, and there's your cube root. All right, this one was a pattern, and you use these pieces with the sign of the problem. So y plus 2, that's your first parentheses. Second parentheses is a trinomial. For the first sign, it's the opposite of that. If that one's plus, this is minus. Last one is always plus. And then all the combinations of your roots. So you take the first root times itself. Y times y is y squared. First root times the second one, y times 2 is 2y. And the last one times itself. 2 times 2 is 4. This trinomial will not do more when it comes out of a cube. All right, let's do 25. So you have 8z cubed minus 125, exponent of 3. So see if you can get cube roots, 2z and 125 we can check. I believe it is 5. So we are doing a cube root, 3, second, any root, 125, enter, and it is 5. So these pieces with the sign of the problem. Second set is a trinomial for your signs. The first sign is going to be the opposite. Last one is always plus. And then you take all the combinations of multiplying the 2z and 5. So first times itself, 2z times 2z is 4z squared. First times the second, 2z times 5 is 10z. And the second one, 5 times 5 is 25. All right. So that one is a form of cubes. This one's not on your test, but you might have to get it right for the review. All right, so cube root of 125 is 5. I didn't try squares out of it because 125 is not a perfect square. All right, and I have to get the cube root here, which will be x squared. If in doubt, you check it, x squared cubed, and then they multiply. So that gives you 6, and so that is x squared should be the cube root. If you write it 3 times, yes. Okay. So this one is 3, and it will be y squared. And so those pieces with the sign of the problem, 5x squared minus 3y squared. Second set is a trinomial for your signs. The first sign is the opposite. Last one's always plus. take the first root times itself. So you're going to have 25, and it will be x to the 4th. Right? Then the first root times the second. 5 times 3 is 15, and it will be x squared, y squared. And then the last one times itself. 3 times 3 is 9, y to the 4th. And that's not going to do more. Those are too high. So you can just kind of check. So we're good there. All right. And then we move on to the solve problems. And for the solve ones, we have the 3 different methods. You have factor with zero product law. You have square root method, which it should be a certain setup to do square root method. Or you have quadratic formula. So the first thing you need to do, unless it's one of the square root ones, is you need to get a 0 on one side. So we need to move that 33, which is going to mess up the product. So I'm just going to go ahead and multiply that out at the same time. And that gives me the 0. We'll see if we can factor it. For 33, we have 1 times 33, and we have 3 times 11. It actually is going to factor with 3 and 11, and you want different signs, and we want a negative 8. So negative 11 plus 3. And then you set each one equal to 0 and solve. So subtract to 3. This one add 11. So 2 answers, negative 3 and 11. Okay. All right. This one I'm going to skip. It would factor, just because the numbers are big and it'll take me a while. It would factor. The reason you know that is because they're giving you multiple choice of the answers, and they work out to be rational numbers. So it would factor. I'm going to skip that one. This one is also going to be a factoring one. Just get everything on one side, 0 on the other side, and then you can factor. Maybe I should look at that one. 5 times. No, it's going to be 5 and 10. So you would get these on the other side. So you'll add 15p, and you'll add 50, and then it will be 0. All right, and 10 and 5. It wasn't clicking for me for a minute. Like signs both plus. And you set each one equal to 0 and solve. So p equals negative 10. And this one, p plus 5 equals 0. P equals negative 5. So negative 5 and negative 10. All right, if I have one of these problems like this with a number here, so I know it's going to be more work, honestly, I would go straight to quadratic formula. I would not try factoring because it might factor and it might not. I would go straight to quadratic formula. So let's do that. Make sure you know quadratic formula. Let's write our problem first. Right, so my A is 6, my B is 13, and my C is 6. All right, and my formula is x is equal to negative b plus or minus the square root b squared minus 4ac. Whole thing is over 2a. All right, so negative b, so negative 13 plus or minus the square root. B squared, 13 squared, minus 4 times A, which is 6, times C, which is also 6. Whole thing is over 2 times 6. All right, so we have negative 13 plus or minus. Going to do 13 squared, 169, minus, we have 24 times 6, 144, over 12. That was a 6. Gonna squish down there. All right, 169 minus 144, 25. So this is actually a problem that would have factored negative 13 plus or minus the square root of 25 over 12. And so we'll go back over here. It says negative 13 plus or minus 5 over 12. You will need to break it apart since they're plain numbers. They don't have a radical or an I. So you're going to, you're going to go, I was trying to switch to red. You're going to go this, I'll go with I call it the high road. So with the plus, that would be different signs, subtract sign of the larger. So that would be a negative 8 over 12, which will reduce the 4. 4 goes into 8 2 times, 4 goes into 12 3 times. You can also use your calculator to reduce. Right, and then I'll go the low road with the minus. So negative 13 minus 5 is negative 18 over 12. These have a common factor of 6. It's going to be negative. 6 into 18 will go 3, and 6 into 12 will go 2. But I think that was as fast as trying to factor it, with the possibility that it wouldn't factor at all, and then I would have to do this. All right. This one is going to get an extra variable out there. So 31. So you're going to take out a GCF. And we have to see if this will factor. I am thinking that it will, because of where it is in the questions. Let's try this one by grouping. And we have to remember we have this W. All right. So if we do 15 times 3 is 45. And they're going to multiply to give 45, and then we'll subtract to give a 4. You can make the whole list, 1 times 45, blah, blah, blah. 5 and 9 are going to work. All right, and I want a minus 4, so I need to do a minus 9 and a plus 5. All right, you keep the first. We're going to do a minus 9. I'm going to put the plus 5 first because it has a common factor with the 15. Plus 5, it gets a W. A minus 9, it gets a W. These two have to give you the one above. Last one comes down. So now we'll do it by grouping. So we'll take out a 5W, and that leaves 3W plus 1. Here we'll take out a minus 3, and that leaves 3W plus 1. We'll double check. There's minus 9W minus 3, so it's good. These match. 3W plus 1. Pick up these pieces, so 5W minus 3. Bring this W down, and don't forget what you were doing. You were going to solve this, and so you have 3 answers you're going to get because the exponent was 3. That's how many answers you can get. So we set the first one equal to 0, and it's actually solved, but that is an answer. Right, this one will be a two-step. You're going to subtract your 1. So we get 3w equals negative 1 and divide by 3. So negative 1/3, this one. Add your 3. So you have 5w equals 3 and divide by 5. So w equals 3/5. So 3 answers, 0, negative 1/3, and 3/5. Right, I'm going to skip these radical ones for just a minute and do them last because we did them last in the class. All right, so we've done some where we've factored and used the zero product law, and we did one with quadratic formula. Let's look at some that are square root method. In the square root method ones, you have something squared equals a constant, and it could be a binomial on this side. And so this one is set up for that. You have something squared equals some number. You take the square root, and it'll be plus and minus on that side. So when you do the square root on this side, it will make the exponent cancel. So we end up with 5m minus 6 equals plus or minus square root of 100 is 10. All right, and so now you're going to solve. So we're going to add the 6. It goes in front of the plus and minus. So 5m equals 6 plus and minus 10. And then divide by 5. Right, and this one you need to work out because it's all numbers. So first go with your high road. 6 plus 10 is 16 over 5. That's one answer. 6 minus 10 is a negative 4 over 5. That's the other answer. Right. This one is the same kind, but you have to make sure that you isolate that square piece first. So I'm going to move the 4. So I'm going to add a 4 to both sides. And you have to divide out this 6. So you have x minus 6 squared equals 6 into 54 goes 9. Now you're ready to use the square root method. So square root of both sides. So x minus 6 is plus or minus. Square root of 9 is 3. And this is another one where we're going to have a number to actually work it out. So add your 6, but make sure you do it in front of the plus and minus. So x equals 6 plus and minus 3. 6 plus 3 is 9. And 6 minus 3 is 3. So 9 and 3. But the key was isolate your square piece first. Right, let's look at this one just a minute. The reason that this problem is good for square root method, even if it didn't say it, is because it has no h to the first power. Right? See, it goes from h squared to constant, so no h to the first. So that is why you would use square root method. Now, you do need to isolate the h squared before you use the square root method. So I'm going to add the 180 to both sides. That leaves me 4h squared equals 180. Divide by 4. That leaves me h squared equals, let's let's see, 180 divided by 4, 45. All right, so now I'm ready for a square root method, but you have to get this square piece alone first. So now take the square root of both sides. This will cancel, that leaves you h. Now 45 is not a simplified radical, so you can break it down on this side. We could do 9 and 5, and 9 gives you square. So you're going to need to take the 3 out. It's going to go right against the radical. So plus or minus 3 times the square root of 5. Okay? I'm going to skip the next one because it'll be the same. Move the 96. Actually, let's do it. It's going to give you eyes. Okay. So 2c squared plus 96 equals 0. So subtract the 96 from both sides. So you have 2c squared equals negative 96. Divide by 2. Divide by 2. C squared equals negative 48. So you're going to take a square root of both sides. All right, and this gives us C equals plus and minus. You're going to take an I out, and you have to see how to simplify the 48. So for 48, I see 6 times 8, 2 and 3, and 2 and 4, and 4 keeps going. So I have actually 2 2's that go out, which will multiply and give me a 4. And that is going to leave a 3 inside. I would probably write it as 4i, but I had already written the I. And that's your answer on that one. All right, and the reason it said that, these are complex solutions and they ask for real solutions. If you solved and got this, if you have this on your paper, I would give it to you. I would just always ask if it was on paper, solve it. You know, I would not differentiate between real and complex. All right, square root method, perfect there. And quadratic formula. All right, let's do one more quadratic formula. I'm going to look at the answers, see which would be a good piece. That's the one I want to do, 43. All right, so we have 4x squared plus 8x equals negative 7. All right, when you look at this, it is a quadratic equation. You need to get the 7 over to this side. That will give you standard form. And any like this with a number here that's not 1, I would go to quadratic formula. It might factor, it might not factor. I would go to quadratic formula so you don't waste time. So my A is 4, my B is 8, my C is 7. So x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. All right, so negative b, so negative 8, I'm going to back up a little bit, plus or minus the square root of 8 squared minus 4 times a times c all over 2 times a. All right, we have to clean up under here. So we have the negative 8 plus or minus. 8 squared is 64, and it is a minus here. 4 times 4 is 16, and we have 16 times 7. Pretty big. 1, 1, 2, and this is over 8. So 64 minus 1, 1, 2 is a negative 48. All right, and so we're going to simplify this radical. I think we did 48 recently, but I don't have that page. I think we had it just on the other page, so I'm going to just write it right here. So I know there is a 16 in it. 16 times 3, if I went that way. And 16 is a perfect square. So the square root is a 4. That's what's going out. You can break all the way down, which is what we did before. So we have negative 8 plus or minus. A 4 is going out. And the I, because of the negative, times the square root of 3 over 8. This one has one more step of simplifying to do. Because in this triangle around the plus and minus, those all have a common factor of 4. So you can divide that out. So we'll divide each of those by 4. So 4 will go into 8 2 times, negative 2. 4 goes into 4 1 time, so it crosses off. And 4 goes into 8 2 times. And remember, in the software, you'll have to split your answer up. So you'll do the fraction button first, but you'll do it once with plus, finish it, do your comma, and then you'll do it once with minus. And Mrs. H has the wrong answer. That's not cool. Anybody know what I did? Oh, you know what? My answer is the same. All right. And I'm going to put it in there and see if it marks me right or wrong. They separated. They separated this from this piece. And so it's negative 2 over 2 gives you the negative 1 plus your square root of 3 over 2. I'm going to type it in and see if they would fuss about that. If I put it all in as 1, they should not. On paper, I would take that answer, so they should take it. All right, so negative 2 plus I times the square root of 3. I always like to put my I in the front. They do it at the end. Too easy to get it under the radical if you do that. All right, now I'm using the arrow to get to the end of that. Comma. Fraction button again. Negative 2 minus square root. Oops, I was going to put the I first. So they accepted it even though they wrote the key out different. Okay. I promised to go back to some of those radical ones. So that was the last thing we learned. All right, so these are not quadratic equations. It's really a whole different kind of equation. If it has a radical on it, you raise both sides to the power of the index. If it's an even root, you have to check. And before you do anything, you isolate the radical. So we're going to subtract that 1. So we have square root of m minus 20 equals 2. Square both sides. right? That removes your radical. So we get m minus 20 equals 4 out of 20. So m equals 24, and you have to check. So square root of, in the original is where you check. 24 minus 20 plus 1, does it equal 3? All right, 24 minus 20 is 4. Square root of 4 is 2. 2 plus 1, does it equal 3? Yes, it does. That means our answer was correct. And that's your answer. Don't get it confused with the check. 33. So you're going to isolate your radical. Move your 3. So we're going to add a 3. So 2m minus 15 equals 13. Now you can square both sides. It is a square root. That will remove your radical. So you have 2m minus 15. 13 squared, I believe, is 169. And now it is a two-step equation. Add your 15. And divide by 2. 2 of 118, 9 times, 92. All right, so we're supposed to check that. So 2 times 92 minus 15 minus 3, does it equal 10? So 92 times 2 is 184 minus 15 is 169. Square root of that we did a few minutes ago is 13 minus 3 equals 10. Yes, it does. Answer is m equals 92. Right. And I was looking for a different word problem. I'm going to go ahead and give you guys a hint. I don't have one in here in the practice. Your word problem is a Pythagorean theorem word problem. So make sure you go back and do that. There were 3 of them in one of the sections. I don't remember which section. Probably this section. But try those, okay? Or maybe it was in solving the square roots. That's going to be your word problem, is Pythagorean theorem. All right, so you guys had a little hint there. This one is going to make you square this side, right? It does have your radical isolated, so you're going to square both sides. But that's going to make you write it twice and do FOIL. Not a very pretty problem. So we get 36x squared minus 66 and another minus 66. Minus 132x and plus 121. All right, I did outside and inside in one step. All right, it is a quadratic equation. So you need to get rid of one of these x squared terms. So I'm going to get rid of this one so that I'll have a positive leading coefficient. So I'm going to add 6x squared to both sides. And that leaves me 11x. And I would probably yell at you for this, but I don't have a lot of room on here. So I'm going to get rid of them both. I would tell you to do one step at a time. All right. So this will give us 42x squared minus 143x plus 121. Wow. That is a mean problem. If you look at those problems on the test, if you have one like that, you leave it till last. Okay. It's always okay to skip and go back. All right. Let's see. I'm not going to do quadratic formula. The numbers are just too big. I am going to try to factor it with 6 and 7. And I am going to try 11 there and see what happens. So that is a minus 66x and a minus 77x. And 7 and 6 is 13. And 13 and 14. All right, so Miss H got lucky there. You can just count that to experience, okay? But it's not a nice problem. All right, and so then you set each one equal to 0 and solve. 6x minus 11 equals 0. And 7x minus 11 equals 0. Add your 11. So 6x equals 11. Divide by 6. 11, 6. Add your 11. 7x equals 11. Divide by 7. And 11 sevenths. All right, so 11 over 6 and 11 over 7. When you plug these in, you're supposed to check. I'm going to bypass that check because one of them probably is going to get thrown out, or maybe both. Let's look and see. All right. Yes, if you put 11 over 7, so when we do the check, the 11 over 7 is not going to work. But the check is even not nice. If they both had the same thing, that would cancel. All right, but it was a square under there. So we could do it. It would take 20 minutes. We're going to skip it. Okay, so you would not want to answer the one that didn't work. So make sure you check. This one doesn't work. Okay. All right. I am going to stop there. I've used all your time. I will look forward to seeing your tests. Okay. And I'm going to turn that test on, and that's my next chore. Okay. All right. You guys have a great day.